What's up guys, I'm S2 Jesse, welcome to part 3, making Ray's blaster. Today we're going to be making some of these parts out of aluminum. It's going to be kind of a short one. Let's get going. This video might be a little light on machining, but I've been preoccupied researching this Tormach PCNC lathe. So I just purchased it. I got all kinds of cool accessories like the 8-tool turret, and I'm really excited to get it, and I'll be using it in a lot of future videos. So I'm using SprutCam again to do the 4th axis cam work. I found out through some feedback from Autodesk that I could have probably done a lot of this 4th axis positioning stuff in Fusion 360, which I would have preferred because their HSM is really cool. I'm not sure if Fusion would have supported these contours, but I know they have full 4th axis stuff coming in the future. Alright, let's get the milling here. So just using a 1/2 inch end mill here to just kind of take out all this material. Not the most efficient tool path. That's why HSM is really cool. If you could have used Fusion 360 for this stuff. Things of pocketing, it's working fine. A little bit of chatter and a little bit of squealing in the corners, but next we'll cut the little slot for the side panel. Sorry for the neighbors, it's a lot of noise. A little cleanup pass. It's got a pretty good surface finish even before that cleanup pass, surprising for how big of a cut that was. Now this section is a little bit of a problem. Cutting the slot like this is leaving a little ridge in the middle, and I'll kind of show that later. Next, use a 1/4 inch end mill to cut the little recess for the side plates. I just want to do a quick pause here because my 4th axis is kind of making this weird binding noise. I don't know if it's a vibration, but it's a brand new 4th axis. I don't know if somebody from Tormach or maybe a user experienced this. I've got the backlash set per their instructions. I haven't actually checked it with a dial indicator or anything, but I'm pretty sure it's set up pretty good. So it's not doing this all the time. It just kind of, at various spots around the rotation, it's giving me this binding noise, and you can hear it in the video next, so I'll play it now. So if you have any idea what that could be, put it in the comments for me, help me out. So I'm sure you can hear it, it's pretty clear. I got it all totally lubricated, filled with oil. All the oil spots are all oiled up. Maybe it's normal, maybe it's not, maybe it's just a noise vibration. But if you know what it is, let me know, because it's a little bit unnerving. I don't really want to use it until I'm sure it's okay. Let's get back to some milling. So first I spotted the holes, and then I drilled them out with a real light peck just to break the chips. Drilled them out for 632 threads. So I wanted to do all the slotting on the mill too, even though it's like really inefficient because this end mill is so tiny, 1/32, and my mill has a really slow max RPM. I just wanted to be able to just chuck it all up and make a whole part with one button press. Problem is I kept breaking this end mill, and it's really inefficient. It's a long cycle time just for those little slots. So it's probably much better to do them on the lathe anyway. So I broke all my end mills. That's what I'm gonna have to do anyway. All right, guys, quick safety tip. Watch where all your metal shavings are flying. When I was cutting that piece off, I saw a nice little spark or flame or something, and tricked the breaker, so it looked like a bunch of chips probably just flew on that plug right there, and they must have been exposed. Anyway, that was fun. Just using the 3D print to line up the lines, and I'll scribe them and just cut them in with that little lathe tool I made. Then I just use Fusion 360 to do all the cam for the top and bottoms, front and back faces, and I just did some face milling and a little bit of pocketing and some drilling. Some of those holes are to hold it together, and some are just clearance holes for other screws or bolts on other parts. So onto the milling. The nice part was one of the sides is flat, so I didn't have to make any special fixturing to hold it. I just chucked it in the vise, made sure it was square. I used my 3D probe in order to get the X, Y, and Z 0 offsets, and then just started cutting. So here's that face mill, then a little bit of pocketing, and then some holes, and then I pretty much just had to flip the part over and then refine my X and got the other sides. All came out pretty nice, decent surface finish, pretty smooth. Next, I just tapped all the holes by hand using a 632 tap. If you never tapped before, you just want to gently start it, make sure you're going in straight, and when you feel some resistance, you want to back off and break the chips a little bit, and then make sure you stop before you bottom out. So cutting this channel on the 4th axis wasn't the best idea. It kind of created this little ridge in the middle due to the radius of the part. The cutter can't quite get there in the middle. You know, you can't really tell, it's like a real subtle hump, but I want this thing perfect, so I'm basically just going to file them down using a file, and then I'll take some sandpaper and clean it up even more. And once I polish and buff it, it's going to look perfect. So again, future ones, definitely just going to cut all these grooves on the lathe. It's going to be much easier and a little more accurate. So I can't resist. I always got to test fit and try to put everything together, even if I just finished one little part. It's pretty fun. So far everything fits together like completely perfect. Pretty happy with how this thing's coming together. Yeah, it's all together, and again, fits perfectly and starting to take shape. These are the torque security screws that I'm actually going to use to put them together. I just don't have a driver for it right now, so I'm just using temporary ones. But people have been asking me where to get them. You can get them at fastenal.com. You can get them at McMaster. There's a lot of different places online to get them from. Alright guys, other than the tip and this little guy, that's all the more complicated pieces. Everything else is just pretty much flat 2D cutouts from different thickness aluminums. So grooves might be a little tricky, but anyway, until next time.